Hi, I'm Jane Hill at the Thayer School of Engineering at Dartmouth College. My group focuses on infectious disease diagnostics. In particular, we're interested in respiratory diseases, and we use engineering tools from physics, tools from chemistry, biology, and medicine in order to come up with a rapid, non-invasive diagnostic.
So you've heard of nasty antibiotic-resistant bacteria. That's what Chris is working on, is trying to figure out a rapid way of identifying them so that people can be saved earlier.
That's the goal?
Yes.
Let's say you have a respiratory tract infection, a lung infection. Then the way that you're typically diagnosed is you have to cough up something. I know that's unpleasant, but it's true. That something is called sputum, and that's typically sent off to the microbiology laboratory, where they take anywhere between 1 day and up to several weeks in order to figure out what it is that you have, which is clearly not enough time when you're sick. So we're working on a way in which to do that much faster. And some of the organisms that we're looking at include everything from the big killer in the world, tuberculosis, to things that are more important here in the West, like Staph aureus, Haemophilus influenza, the flu, as examples. We're also able, which is very, very cool, to distinguish between antibiotic-resistant organisms and those that are not. And for some patients, I mean, that time is critical. If you're on a ventilator in a hospital, your prognosis goes down very, very rapidly over time if you have an infection and you don't know what it is. So if we can determine what the patient has within a few minutes, which is what our test is aiming to do, then there are a lot of lives that can be saved. No, I'm not originally from New Hampshire, although I've spent the past 20 years or so in New England. But I originally grew up in Australia, with a lot of sheep and wheat. It's a great place to grow up because we were always outside and doing things with animals and plants and whatnot. I was allowed to explore as a child. Everything from being given a microscope when I was really young. Microbes are awesome.
And people breathing.
I mean, think about the simplest kind of microorganism. Think about a virus. Think about Ebola, okay, and the huge impact it's had, even though it's been mostly from afar. It's a tiny, tiny thing with just a few genes, and yet it can cause incredible havoc to just human society. So I work at organisms that are more complicated in the terms of the number of genes, and we're very advanced in science, but we have so much to learn about the smallest of our creatures. It's fascinating. When you think about life, it's incredibly short, and being an engineer, we're given the tools to do things that are very applied. So as much as I'm fascinated by the fundamentals of these organisms, being able to do something that has an impact it's something that gets me up every single day. Literally, sometimes every single day, being excited about my work.
Yeah. Whoa, Nelly.
It's awesome to think that in maybe 5 to 10 years, we'll be able to diagnose diseases with a breath, an infectious disease with a breath. A simple one breath can tell you if you have tuberculosis or not, and then you can go on to treatment immediately. Or if you have an MRSA infection, so you can immediately go on to the right course of antibiotics. I mean, that's exciting. A lot of what we do once we move beyond the proof of concept involves patients and physicians. So there's a lot of personal skills that are required, and you may not think engineers require personality skills or emotional intelligence, but it's a critical part of our work. And actually, I think it's a critical part of engineering no matter what you do. You can have the best idea to clean water in the developing world, but if you can't communicate that effectively and obtain community feedback, then it doesn't matter. The hopes are that we will create a one-breath test for lung infection diagnostics. And I suspect that the work we're doing could be realized perhaps in the next 5 to 10 years. We're working with folks right now, hundreds of different patients from all over the world, in order to do the ground truthing for that work. So to discover what those biomarkers are. And then once we have those confirmed, then we work with people who make point of care devices to translate those biomarkers to the patient. And that's probably a 5 to 10 year process. I just think learning's really interesting. I think once you get the bug of being curious, sometimes it's not a common thing when you're undergoing some kind of education. You're often learning facts or ways of doing things, but when you can reignite that enthusiasm and curiosity about the world, then the world looks different. If you really want to do something, then science and engineering will give you the skill set to do it. Not just to talk about it, not just to worry about it, but to actually create solutions, whether it's climate change or infectious disease related or discovering the cure for cancer. Science and engineering are the only tools that will get you to that point. The rest is for culture. And I love culture. In or out of the flask.